On our first set of notes, it says a blank is a comparison of two quantities using division. That is a ratio. The ratio of quantities A and B can be expressed as A to B, A colon B, or A divided by B, where B does not equal 0. Ratios are usually expressed in fractions. And ratios or fractions can be used to compare 3 or more quantities. Can we stop talking while I'm talking?
Right.
Thank you. So normally we would have 2 of them, like 2 to 3. But you can have 3 of them, like 3 to 4 to 5, which means the ratio of the first 2 terms, so you close it off. And you look at it as 3/4. And then you look at the last 2 terms, and you get 4/5. And then you take out the middle, and you get 3/5. So it's 3 different ratios because it's 3 different comparisons. That's a ratio. Isn't it magic? Ready for our first example? Brian's going to help us with it since he's bent on talking. Okay, can you stop now? Thanks so much. In our first example, it says in Logan's High School there are 190 teachers and 2,650 students. What is the approximate student-to-teacher ratio at his school? So, what is going to be on top of our fraction? What is it asking us for? No, it's asking us for students to teachers, right? And as they said back there, they said the student number, which is 2,650, is going to be on top. What's going to be on bottom? How many teachers are there? 190. Now, it's a fraction. What do we do with fractions? No, it depends on the way you read it. So this said student teacher. If it said teacher to student, you would flip it. Now, what do we do with fractions?
Divide.
So take your handy dandy calculator and divide that.
13.9.
Okay? Now, Mazzaro, can we round that up and create a whole new person?
Yeah.
Or should we can? Out of thin air?
I'm sorry, never mind, I'm sorry.
So would we round down and have it as 13, or would we go up and round it as 14? Okay, guys, we had 13.9, right?
Yeah.
We can't create a whole new person.
Until the
So
one
we just
part
round
of the
down.
person is
Round
gone.
down.
So we would round down to what?
13.
So that's 13 students to how many teachers? When you divide it, what's left over? 1. So what happens is you're lining up all these students, right? And you're saying you 13 go to that teacher. And you 13 go to that teacher. And you 13 go to that teacher. How many teachers are you going to? You're going to one teacher at a time. So it's 13 students are grouped together going to one teacher. Now you cannot round up and create a person out of just thin air. That 0.9 is still not a person. Unless they lost a body part. Okay?
You just sacrifice the arm.
Alright, you sacrifice that arm and then let me know how it goes. Let's look at number 2.
Wait, was one just like one teacher? You can do it like that?
That's what we just explained.
13.
Yeah. So that's 13 students per teacher. Now, you can go on school websites for colleges, and if you want one that has a lower class ratio, you look for stuff like this. You can also look at Alabaster's website, and usually it says we've got like 15 to 1. How many kids are in? But I digress. Number 2. A baseball player's batting average is the ratio of number of base hits. We all know what a base hit is, right?
No.
It's where you hit the ball, you get on base.
Wow. Make sure you should say something. Ain't you play baseball?
Okay. To the number of at-bats. What are at-bats?
At the bat.
When you at the bat, yes. Okay. So the number of base hits to the number of at-bats, not including walks. Minnesota Twins' Joe Mauer had the highest batting average in Major League Baseball in 2006. Not 3006. Let's fix that.
I'll be married by then.
Wow, we're still throwing baseball? I thought they'd have something else to throw.
If he had 521 official at-bats and 181 hits, find his batting average. Now, what's going to go on top based on what it said in the first sentence? No.
Base hit.
Base hits goes on top.
Yeah.
Now, let's reread that sentence. The ratio is the number of base hits to the number of at-bats. So base hits goes on top. What goes on bottom of our fraction? At-bats. Now, it's asking us for our batting average. So besides Blake, does anybody know what your batting average is usually listed as? Is it a fraction, a whole number? What is it as? No.
I don't.
It's a decimal. It's a decimal. Because you're not going to hit the ball every time you get up to bat. You just not.
Oh, you strike it one
All
time?
right, so how many base hits did Homeboy have?
5.21.
No, that's his at-bats. How many base hits did he have? 181. And how many at-bats did he have? 521.
He's Babe Ruth.
No.
No, that's not.
No, he's not.
So
He's
these
not
ain't
even
good
close.
averages.
We'll have to see how it goes.
Right. So divide it and tell me what you get. You need 3 decimal places for a batting average.
0.34.
I'm sorry. Experience something outside of your world.
Oh, this is not even
So what'd you get?
0.347408.
So 0.347?
Yeah.
Because we need 3 decimal places. That's his batting average.
Oh, that's true.
So this is 3 tenths, right? That's what this is right here. So 3 out of 10 times he got a base hit. So every 3 bats out of 10, he got a base hit. Is that good or is that bad? And that was the highest batting average in Major League Baseball in 2006. And they wonder why people don't watch it. Let's do number. Let's look at number 3.
We watch it for people to miss in the outfit.
I'll make it.
Number 3.
Maybe next year, guys.
Number 3 says that the ratio of the measures of the angles in a triangle is 3 to 4 to 5. Now, what do we know about the total measure of a triangle?
It's 360. 180.
Kill me now.
I said
It's 180.
Yeah.
So what would we, now, what is our first angle? Is it 3? These are our angles, right?
Yeah.
So you would do 3x plus what?
4x,
Plus,
5x,
and we would set it equal to?
180.
Take 2 points from 0.
Okay, take 3 places.
No.
I thought about it.
You should be writing this down. It looks like you're playing with your bottle. So let's put that down and write. You do add these up because we're solving an equation.
Take a point.
No. And x equals 15. Now, it asks us to find the measures of the angles. Now that we have x, what would we do?
Plug it in.
Plug it in. Take a point.
Thank you, kids.
So we would do 3 times 15, and then 4 times 15, and then 5 times 15. Work those out, and then tell me what you get.
That's where he said he's plugging it in.
Because we found x, right? But we need the measure of the angles. So we know that the first angle is 3x, and then 4x, and then 5x, so you take your x and you plug it in. Alright, what's 3 times 15? What's 4 times 15? And what's 5 times 15? Awesome. Stop doing that. Alright, any questions on number 3?
Nope.
Ratios are pretty easy so far.
Yeah.
Lupita, Taylor. Alright, let's look at number 4. In a triangle, the ratio of the measures of the sides. So So if it's sides, are we going to set those equal to 180? No. No. We're not done reading the problem, but you don't set sides equal to 90 or 180. It is a side length on an angle. I've been saying it for 3 weeks every day.
That's a month.
I said that.
No, we got to read the problem.
I'm sorry.
All right. It says that the ratio is 2 to 2 to 3, and that the perimeter is 392. What does perimeter mean? That all the sides added up. So what are we going to do with these?
Add them together and set them equal to 390.
Yes. Now what's our first side length? 2x plus 2x plus 3x equals.
392.
All right. Find x without me.
Let me solve it.
So now that you have x, what do you have to do to find the side lengths? Plug it in. If only it was funny. Just be Elsa and let it go. Just be Elsa and let it go. Then you did something wrong.
You add the x and then you divide it by 392.
That's what I did.
Did you do 392 divided by
7. What's 392 divided by 7? 56.
Oh, I thought it was a 3. That's why. I did 2, 3, 3, 9.
All right, what are our side lengths?
112, 168.
Good job, guys. How do you feel so far? Like we can handle this? Is this easier than rectangles?
Can you go back to
In a minute. In a minute. Flip your paper over. Now what we're going to do is we're going to set two ratios equal to each other. Does anybody know what that's called when you take two ratios and set them equal? Starts with a P. Proportion. Both of you take a point.
I feel like part of the whole.
That's a fraction. Alright, that says proportion, but my tape wouldn't let me write on it. So that's like saying if you have two fractions, you set them equal to each other. Now, who remembers how to solve a proportion? You cross multiply. Good. Take a point, guys. And that gives you AD equals BC. It says proportion. If you would listen and stop talking, I'll literally say what I write. Right. I literally said it. Proportion. P-R-O. P-O-R. T-I-O-N. All right. Now let's look at number 5. How do we solve this proportion? So what are we going to multiply x by?
44.
And what are we going to multiply 4 by? All right, solve it without me. Not yell it out loud. Just solve it and be quiet. Me too. I know. It's going to be fun with us too because we get to do so many things throughout the whole unit.
Is it a decimal?
Yes. And we're not afraid of decimals, are we?
No, I am.
No, they're friends, not food.
I'm afraid of fractions.
Fractions are friends, not food.
I wish they were.
Well,
I'm hungry too.
I'm gonna be eating something right
I'm
now.
afraid of calculating.
We know.
44 divided by negative 6 is?
7.3.
Negative 7.3.
Oh, my fault. I forgot my neck. That's going to be crucial.
That is going to be crucial. All right, now let's look at number 6. What's different about number 6?
They have
have
a
a distributive
You are going to have to do, I'm so proud of y'all. Take a point.
Hey, I see it.
All right, so you would do 4 times 2x plus 5 equals what? 42.
Oh.
And then distribute. Solve it without me. Let's go, let's go.
you distribute first.
Yes, and then solve it. Look at you go. Write it on your paper. Look at you go. Write it on your paper.
Yeah, 2.75. It's easy.
That's because I taught you this last year.
That would be a good bet.
Where was I?
That'd be decent.
Yeah.
Yes, she did. She saw the road.
That was the highest. All right, number 7. Did y'all get 2.75 for number 6? I got excited. I'm sorry. Now, on number 7, are we going to have 2 sets of parentheses? We are. We're going to do 7 times x plus 4. And then we're going to do 9 times what? All right, finish working it out without me. Mm-hmm. If we finish, we won't have homework.
I believe you can finish.
Well, I mean, I still don't take off
Don't stop.
Okay, that's what I'm saying.
Why?
Hmm?
Why?
I don't know, because I feel like you subtract, not 28.
What?
I feel like you subtract, not 28.
I added 9 to both sides.
Oh.
Because it's a negative, right? Yeah.
I'm sorry.
That's okay. Just watch your signs. Be careful of that. Mazera, let me know when you're ready.
Yes, ma'am.
What are you talking about?
And what do we get for X tater tots? 18.5. Awesome.
Take a point.
How many of us got it right at our table? If everybody got it right, take 2 points.
You know what? We have had
Eric.
5 points today, Shelby. You ain't wrote nothing back. And we got news. We got news. People don't like the I ain't say nothing to the people.
All right, so now let's apply this to a word problem. This says that the ratio of boys to girls at a high school is 4 to 3. So what would this look like as a fraction?
4 over.
It's not over because we're not cows.
4
1/3.
4 divided by 3 or 4/3. Good, Mazero, take a point. Now, is 4 boys or is 4 girls? It's boys. And how many girls? 3. Now, there are 936 boys in the school. Is that good? We're going to set it equal to create a proportion because we're looking for how many girls are there. So what's going to be on the top of this fraction? Boys, 936. Now remember, if boys are on top over here, boys have to be on top on the right. 3 is on bottom, and then we're looking for the total number of girls, so we call that X. And now what do we do to solve? Cross multiply. Isn't it crazy?
Why has to be girls?
Do you want it to be Z?
No, I like it.
I think so. Tyler, why don't you work it out and see what you get? Cross multiply.
Did you get the girl group? Did you get the girl group?
We have to finish
702? Oh my gosh.
What?
We have to finish the entire thing.
That's our goal.
702.
Would you rather have some homework so you can practice this? Alright, what'd you get for X? Alright, O is a letter.
0.
So 702. O is a letter.
You said 702.
That's a girl.
That is my biggest pet peeve. Well, that's not a true statement. With numbers, that's my biggest pet
You have
peeve.
a lot of
I know I'm a picky person.
breathing, talking, asking questions that I don't think is stupid. But you
Axing, yes, axing people. I have an issue with axing people instead of asking people.
asking.
Because they dumb. Alright, now let's look at the bottom of our notes. And we are almost done for today. Isn't it exciting? Alright, so now what we're going to talk about is the last part of our learning target. So it said I can write and solve proportions and use this knowledge to interpret scale models. So a scale ratio is a unitless ratio in its simplest form. Always write the length of the model first in the ratio. Make sure you are using the same units before you reduce the fraction. So if you guys ever bought the model cars and it says like 6 to 47 or 2 to 35 or something like that, those are scales, and that's what we're going to be creating. And hopefully we'll have a project that can help us build one, and it's going to be super fun.
Make us a car.
Maybe a car or a building. What would you rather do, a car or a building?
A building so it can be like all streets, like
Yeah.
a mansion.
Okay.
That I can't.
Alright, so now, our first problem, and it says, make sure you are using the same units. The same units, the same units. Underline that. Circle it, star it, heart it, baby Jesus, Raven, stop talking so you know what I'm talking about. Because when you ask a question, I'm going to say you were talking, you should have been listening. Go team. Alright, number 9 says the miniature not leprechaun, replica of a 1923 checker cab is 6.5 inches. The actual length is 13 feet. What is the scale factor? Now, we have inches and we have feet. What do we need to do?
We need to make inches into feet.
I'm going to go with feet into inches. I think that might be easier. Don't y'all
Is
think?
there 12 inches in a foot?
Yes, there are 12 inches in a foot. So what would we multiply 13 by?
12.
All right, so let's do 13 times 12. And tell me what you get. 156 inches? All right, write that down. Now, did it tell us to write our scale down first or the actual length first? Let's read it. Did it say, is it always write the length of the model first? So what should we write down first, 6.5 or 156?
6.5.
All right, so we're comparing 6.5 to 156. Now, does that make any sense?
No.
What could we do to make it make sense?
We can divide and we can put it
We could divide it. What else could we do?
Multiply.
and together by 2.
What do you think? Set it as a fraction? Okay. So we have 6.5 inches divided by 156 inches. Divide that and tell me what you get.
0.0416.
Can you turn that into a fraction for me? It's what? It's not over anything because we're not cows.
Okay, you know what?
1 divided by 24? Awesome. Alright, let me see somebody's calculator. Nika, can I borrow yours?
Yeah.
Alright, so you have this right here, correct?
Yeah.
Turn it into a fraction. Now you're going to look for the button that says the F to D right there. And you hit second and that button.
I remember this.
And you get 1 divided by 24.
I remember this. I remember this.
It's not over. That's not a mathematical operation and we're in math. Yes, ma'am. Can you bring it to me? Here, Nikki. Alright, so that means for every 1 inch on the scale, you go 24 inches on the, for 1 inch on the model, it's 24 inches on the actual car. So 1 inch would equal how many feet? 1 inch would equal how many feet? 2 feet. Good. So you do mode. Nope. Oh, it's been so long since I've done this one here.
What you got going on them?
I will even give you 2 minutes to clean up your tables, and we'll stop for today.
Oh my God. What
De nada, no homework,
No homework. For the first
no tarea.
for the first time in 12.
You have to